Hi everyone, welcome to the Low Temperature Thermochronology course. Today we are going to discuss the second section of Chapter 10, that is Post Late Jurassic Cooling History of Mountains in the southwestern Ordos Basin. 4 topics are concerned in this lesson: introduction and sample collection, methods and research procedure and results, cooling history, annealing zone division. Geological settings of the Ordos Basin have been introduced in previous lessons. The southwestern Ordos Basin as a junction area of the Tianhuan syncline, the western margin thrust belt, the Weibei Uplift, the Weihe Basin, the Liupanshan Mountains, and the Qinling-Xilian origin, is important for studying the coupling relationship between southwest of the North China Block and its surrounding orogenic belts. It belongs to the combination of several geological plates and has undergone multi-type of tectonic movements, resulting as a diversified tectonothermal evolutionary history. In the regional geological map, as shown in the left figure, the Cretaceous systems are widely and continuously exposed in this region, except for the south of the western Ordos Basin, where the residual Triassic and a few Triassic strata separated the Cretaceous strata into several parts. Besides, maturity of salt rocks in the south of western Ordos Basin is much lower than that of the same sedimentary formation of its nearby areas. Therefore, what's the tectonothermal evolutionary history of the south of western Ordos Basin, since Mesozoic that causes this geological phenomena and its differences with the south of the Liupanshan Mountains and the northwestern Weibei Uplift. In order to solve these problems, a study using an integrated method of thermochronology was carried out. Geological routes which are convenient for investigation and sampling were selected for fieldwork. Formations that suffered a certain degree of erosion since Mesozoic and exposed on the ground at present recorded the thermal evolutionary information. Epithet and zircon minerals of sandstones were collected with record of sample location and elevation. 12 sandstones were collected from the Jixian system, the Permian, the Triassic, the Jurassic, and the Cretaceous, respectively, from fresh outcrops with weight of 5 kilograms for each sample. 2 sandstones were collected from the Jixian system and the Triassic system for vitronite reflectance analysis. LASAP-MS-based epithet fission track, epithet helium, zircon helium, thermochronology, and vitronite reflectance were carried out. General procedure of this research was as follows. 1. Calculate the maximum paleo temperature using vitronite reflectance data. 2. Filter out fission track and helium edges not suitable for thermal modeling. 3. Geological interpretation of thermochronology data were discussed. 4. Cooling time and temperature paths were modeled using the HIFT program, and the best temperature time paths were figured out. 5. The epithet fission track annealing zone was discussed. Here lists a set of data, including measured RO, calculated the maximum and epithet helium data. Data of Zircon helium analysis. Arithmetical mean value of epithet fission track ages. Some samples have one age population, but some have two. Age decomposition of samples were made using the software of radio plotter. Inverse modeling of cooling history for each sample was conducted using the HIFT program with fission track data and ViewNet reflectance data, as well as helium data. The indices for both the age data and the length data for all samples were higher than the expected value, indicating that the modeling results were highly reliable. The fission track data in this study are roughly in the same range as those published data by previous studies, and there are no differences in order of magnitude. Besides, this work has added some new thermochronology data for the southwestern Ordos Basin. Annealing zone is the key for analysis of uplift cooling ages and process. After the time that a sample reached its maximum barrier temperature, it would cool down due to the uplift or decrease of geothermal gradient, and epithet from the total annealing zone once again begins to accumulate the tracks and record an epithet fission track age. This data can be used to determine the time, speed of cooling event, and to provide information for the uplift and denudation. 3 cooling events were classified based on the epithet fission track age variation with depth and the degree of annealing: Late Jurassic, Late Cretaceous, and Late Miocene. In this lesson, we compare the differences of post-late Jurassic cooling history of several parts of the southwestern Ordos Basin. This work shows that cooling history of mountains can be well recovered using thermochronology and ViewNet reflectance data, and can provide a basis for research of petroleum exploration of these regions in the future. That's all for this lesson. Bye-bye.